My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem-solving questions. It says 174 data sufficiency questions. We have already solved every single math problem from this book. If you're interested in watching the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are redoing the problems. We are on page number 158. Page number 158. The very first problem on the page. It says the point that is twice as far from P as it is from Q. We're looking for a point that is twice as far from P as it is from Q. Here is point P that is shown to us right here. At point P, which is 0 and -1. That's our point P. That's how they show it. And then it goes through 1, 1. Rather 1, 0. It goes through that point. And they're calling that point, actually they don't give it any name. The next point that they show us is 3, 2. 3, 2. 2, 3. 3, 2, and they're calling this point Q. The question is, where is that point which is twice as far? We're looking for a point that is going to be twice as far from P as it is from Q. Well, it's very simple actually. It's already been divided up in 3 parts for us. It's already been divided up into 3 parts for us. If you look at it here, the line has already been divided up from 3 parts. This is the first part, this is the second part here, and this is the third part right here, because it goes up to 3. So, since we want it twice as far, this point right here is this point. Let's call it R. Point R is the one that is twice as far from P as it is from Q. If you measure along this line. And the coordinates of points R are going to be 2. It's going to be 2. And the Y coordinate is going to be 1. 2, 1. So we're looking for 2, 1. That's answer choice B. And that's answer choice B. Let's go on to the next one, shall we? Number 41. Number 44. Number 44 tells us that n is an integer. N is an integer. The question is, which must be even? Pay attention. They use the word must, not which may be even. We may find something, we may find an answer choice which may or may not be even. We're looking for something that is even all the time, which must be even. Well, the very first answer choice they give us is n plus 1. Well, n plus 1, without knowing anything at all about n, simply knowing that n is an integer, we cannot tell that it's an even. It depends on the value of n. If n happens to be 3, then 3 plus 1 is going to be 4. It may be even. But if n happens to be 2, then 2 plus 1 is 3, which is not even. So, answer choice A contains a quantity which may or may not be even. We're looking for something that has to be even all the time. Let's look at answer choice B. Answer choice B says n plus 2. Now n plus 2 will have the same exact argument as this one. Depending on what n is, it may be turned out to be 2 plus 2, which is even, or it may be 3 plus 2, which is not. It's the same argument. Let's look at answer choice C. Answer choice C says 2 times n. Okay, now listen. It doesn't matter whether n is even or odd. N is going to be either even or odd. So 2 times n, if n happens to be even, then even times even is even. And if n happens to be odd, and n happens to be some odd quantity, then we are multiplying it by 2, and we know that even times odd is also even. So here's a situation where it doesn't matter whether n is even or whether n is odd. It makes no difference whether the unknown quantity n, we know it's an integer, it doesn't matter whether it's even or odd. The fact that it is being multiplied by an even number, an even number times an odd number is even, an even number times an even number is even. So this quantity will always be even. The question is, which of the following must be even? The answer is, this is the quantity. Answer choice C, it contains the quantity, that's something that has to be even. D says n plus 1. That's just nonsense. It depends on the value of the n. How can we tell this that it is even? Answer choice E says n squared. Well, n squared will depend on the value of n. N squared will depend on the. Let's look at n squared here, which is simply n times n. Well, that will depend on whether or not n is even or odd. If n happens to be odd, then odd times odd equals odd. In which case n squared is odd. But if n happens to be even, then even times even is even. So answer choice E contains a quantity which may or may not be even. We are looking for something that must be even. The only quantity that has to be even all the time is the quantity that is presented in answer choice C. C is the answer. Let's move on then. 46. Number 46. 46 or 45? I don't. We just finished 44. Oh, we're looking for 45. We are told that 4 is one solution of the equation x squared plus 3x plus k equals 10. Question is, what's the other? What's the other solution? Of course, it's a quadratic equation. It's a quadratic equation. It has two roots. We are told that one root is 4. What's the other root? Well, let's find out, shall we? Well, the fact that we are told that 4 is one of the solutions, that tells us that if we were to substitute 4 in this equation, the equation should be satisfied. This equation will be satisfied if we substitute 4 in it. X squared plus 3x plus k, we are told, is 10. 4 squared plus 3 times 4 plus k equals 10 should work. From there we can figure out the value of k. K would simply be 10 minus 16 minus 12. 10 minus 16 is a negative 6, a negative 6 and a negative 12 is negative 18. So now we know what our equation is. Our equation is x squared plus 3x minus 18 minus 18 equals 10. But that's not how we write our quadratic equation. The quadratic equation has to be written in its standard form before we can do any factorization. We need to bring the 10 here. Let's bring the 10 over here, subtract 10 from both sides, and we end up with, I don't know why I'm doing it in a childish way. Bring the 10 to the other side, we end up with x squared plus 3x minus 28 equals to 0. This is the equation that we have to work with. We're going to factorize it, and we're going to find the other root. Okay, let's do it together. I'm not going to explain too much. If you're one of those people who has trouble with quadratic equations, you can go to my channel, or you can go to YouTube, just type in quadratic equations along with my name, and you'll find plenty of videos for practice. And if you can't find them, send me an email and I'll send you the links. Here we go. So we're looking for two numbers. We're looking for two numbers whose product is 28, whose product is negative 28 rather, and whose sum is positive 3. One more time. We're looking for two numbers whose product is going to be negative 28 and whose sum is going to be positive 3. That's the tricky part. You have to think of two such numbers. And those two numbers are going to be negative 7 times positive 3. Well, negative 7 times positive 4 rather. Negative 7 times positive 4 does equal negative 28, but negative 7 plus a positive 4 does not equal positive 3. We need positive 3. This is going to give us negative 3, so we got to switch it. We need positive 7 and a negative 4, and that will do the job. Positive 7 and a negative 4. Those are our factors. We're going to break up this 3x into 7x and a negative 4x. So 3x is going to be written as x squared plus 7x minus 4x equals 28 equals 0. If you look at these two terms, we have x common, take out common. I'm not going to explain too much, I'm just going to do it. If we look at these two terms now, negative 4 and negative 28, we can take out negative 4 common. Once we take out negative 4, we are left with only x from the third term. And from here, negative 28 divided by negative 4 is going to give us positive 7. Now we look at this term and that term, and we have this quantity here. X plus 7 is the x plus 7 is the common factor. Take it out common, x plus 7, and we are left with here x, and from here we are left with negative 4, and that equals 0. Since the product of these two quantities is 0, that tells us, that implies that either x plus 7 is equal to 0 or x minus 4 is equal to 0. Well, if x plus 7 is equal to 0, that implies that x must be negative 7, or if this is true, then x must be positive 4. Well, we already told that one of the roots is positive 4. We were told that from the very beginning. We knew that one root is positive 4. The question is, what's the other root of this equation? We just found out that the other root is negative 7. The second root of this equation, of this quadratic equation, is negative 7. The answer is A. Answer is A. Let's move on. Number 46. Number 46. Number 46 says the sum of 7/8 plus 1/9 is between which two quantities? Well, we know that 7/8 plus an 8, we know that is exactly 1. But we're not adding 1/8, we are adding 1/9. 1/9 is less than 1/8. 1/9 is less than 1/8, which means 7/8 plus 1/9 has to be less than 1. Has to be less than 1. We also can tell that we are adding these two quantities here, and we can clearly see that 7/8 is more than 6/8. We already know. If we just look at the first quantity, we know that 7/8 is more than 6/8. And how much is 6/8? 6/8 is a 3/4. So in other words, we know that 7/8 is more than 3/4. This quantity is more than 3/4. Plus we have this one. So this whole thing, whatever it is got to be more than 3/4 and has to be less than 1. The question was, the sum of these two quantities is between what numbers? The answer is the sum of these two quantities is between 3/4 and 1. It is between 3/4 and 1. And that answer choice between 3/4 and 1, wherever that is, that's the answer. That's answer choice B, I believe. But anyway, whatever that answer is, 3/4 and 1, that's answer choice B, I believe. Let's go to the next one, shall we? Enough of the talk. Enough of the talk. Number 47. Give me a break for a second. Number 47. We are told that x equals to 1 minus 3t, and y we are told is equal to 2t minus 1. If then we are asked x will be equal to y, then x will be equal to y when t equals how much? Well, it's very simple. All we have to do is equate these two equations. X equals y, which means this quantity has to equal this quantity. Let's equate them. 1 minus 3t has to equal 2t minus 1. Bring all the t's on the other side, bring the 1s on the other side, and so on and so forth. Let's add 3 to both sides here, 3t to both sides. And let's add 1 to both sides. There we go. So here we have a negative 3t and positive 3t, they're going to cancel out. And 2t plus 3t is going to be 5t. And here we have a negative 1 and a positive 1, they're going to cancel out. And here we have a positive 1 and a positive 1, that's going to give us 2. 5t equals 2, which means t equals 2 times 5. T equals 2 times 5. Divide both sides by 5. And that's it. T equals, not 2 times 5, t equals 2 over 5. And that's your answer, choice D. That was just a silly question. That was just silly. Number 48 is equally silly. It's too silly. It's too simple. Number 48. The next one. Give me 1 second. Number 48. They're asking what's the value of 1 minus 1/2 minus 2/3. Well, 1/2 minus 2/3, the common denominator is 6 here. So we have 3 minus, here we divide by 2, so we get 2 times 2, which is 4. 1 minus this quantity. One minus this quantity, which is 3 minus 2 times 2. 2 times 2 is 4. 3 minus 2 times 2 is going to be negative 1. Negative 1 over 6 minus 1. 1 minus negative 1 over 6, and that can be written as 6 over 6. So we end up with 6 minus a negative 1. This is where you have to pay attention. This negative and negative will become positive, and we'll end up with 7/6. We'll end up with 7/6, and that's answer choice B. Let's go to the next one. Number 49, the penultimate question on the page. The penultimate question on the page. X, we are told, averages 25 miles per gallon. Car Y, we are told, averages 11.9 miles per gallon. We are going to drive 12,000 miles. We are going to drive both of these cars for 12,000 miles. Both of these cars are going to be driven for exactly 12,000 miles. The question is, how many more gallons will you burn if you drive car Y? How many more gallons will be burned in car Y? Notice they're looking for how many more. So we have to figure out how many gallons we're going to burn to make this trip of 12,000 miles with car X. Then we have to figure out how many gallons will burn with car Y and look at the difference. So let's do car A here, car X here, and car Y here. Car X, we're going to drive 12,000 miles, and car X gives us 25 miles per gallon. 25 miles per gallon. As you can see, miles are going to cancel out, and we end up gallons will end up on the top. So we have to divide 12,000 by 25. 12,000 can be written as 120 times 100 over 25. You see, I just took 2 zeros and put them in the 100 because I can divide 100 by 25. I don't want to take the time to divide this bloody thing by 25. So write that down as 120 times 100, and 100 goes into 25 4 times. So we end up with 120 times 4. 120 times 4 is 480. Now let's do car Y. Car Y, we are going 12,000 miles, and it gives us 11.9 miles per gallon. We're going to approximate that, we're going to round that to 12 miles per gallon. So this is the approximate answer, 12 miles per gallon, which is very simple. 12,000 divided by 12 is 1,000 gallons. Car Y burns 1,000 gallons, car X is going to burn 480 gallons. The difference is 520 gallons. The difference is 520 gallons more. We're going to end up burning 520 gallons more if we were to take the same trip in car Y as opposed to taking car X. Car X is the more efficient one. Do you understand? That's all there is. Let's do the very last one, number 50. Number 50 is a little tricky. Just give me 1 second and we'll get to it in a second. In number 50, they're only testing one very simple concept. And you either know that concept or you don't. If you know the concept, the question is very simple. Question is, how many integers, how is the phrase? How many integers n are there such that, how many integers n are there such that this is true. One is this quantity 5n plus 5 is more than 1 but less than 25. Let's find out, shall we? Let's find out. By the way, what does penultimate mean? Penultimate is just a very fancy way of saying second to the last, of course. We have learned these words in our vocabulary lesson long time ago. For those of you who are interested in improving your vocabulary, we learned the word penultimate on day number 11. Just type in GMAT vocabulary words or GMAT vocab words, day 11, and you will find the video where we learned the word penultimate, which simply means second to the last. Let's find out how many such integers are there where this may be true. Well, let's plug in 1 here. 5 times 1 plus 5, 5 times 1 plus 5 is 10, and 10 is more than 1 but less than 25. That works. 10 is less than 25 and more than 1. Let's plug in 2. 5 times 2 plus 5, 5 times 2 is 10, 10 plus 5 is 15, 15 is less than 25 but more than 1. That also works. So far we found 2, we found 1, we found 2. Let's plug in 3. 5 times 3 is 15, 15 plus 5 is 20, 20 is less than 25, but it is more than 1. That also works. Let's plug in 4. 5 times 4 plus 5, 5 times 4 is 20, 20 plus 5 is 25, and 25 is not less than 25. 25 is not less than 25, so 4 would not work. It is more than 1, this quantity is more than 1, but this quantity is not less than 25. So how many did we find? 1, 2, 3. 1, 2, 3. If you plug in any higher number, it won't work. And it says, did I leave something out here? And we can't plug in negative numbers. We can't plug in negative integers because if you plug in negative integers here, 5 times negative 1 plus 5, 5 times negative 1 is 0, 0 plus 5 times negative 1 is negative 5, negative 5 plus 5 is 0, and 0 is not greater than 1. 0 is not greater than 1. 0 is less than 25, but 0 is not greater than 1. So negatives do not work. So how many did you find? 1, 2, 3. And if that's the answer that you picked, then of course you're picking the sucker's answer. The concept that they're testing here, is, I'm going to make a big fuss about it. I'm going to put it on the top. We're going to accentuate it. We're going to put it in a very prominent place. You must keep this in mind. You must keep this in mind for the exam. 0 is an integer. 0 is a whole number. Integer is a whole number. 0 is a whole number. It appears on the number line. This is 0 right here. If 1 is an integer, if 2 is an integer, if negative 1 is an integer, why not 0? 0 is also an integer. It's a whole number. We forgot 0. 0 works. We forgot 0. 5 times 0 plus 5. 5 times 0. 5 times 0 would be 0. Plus 5 is 5. And 5 is more than 1, but less than 25. We forgot the 0. So how many are there? Let's count them. We have a 0 here that we had forgotten. Then we had 1, 2, and 3. 1, 2, 3, and a 0. The answer is there are 4 such integers. There are 4. The question was how many such integers are there where this is true? The answer is there are 4 such integers where 5n plus 5 is going to be more than 1 and less than 25. That's all. I'll see you tomorrow, okay? Where we'll begin the new page. Okay? Bye now.